So the carbon-13 NMR spectrum for 2-pentanone is shown below. And so it's asking you which carbon atom corresponds to the signal at 14 parts per million. So that's this signal here. So that's what these numbers are. It's telling you where on this bottom scale. So this is definitely in the sp3 carbon portion of the spectrum. So the only signal that we have that's not in that area is here, and this is for the carbonyl. And carbonyls of ketones are usually pretty high like this. You're going to see them at approximately 205 to 220 ppm. So that's your ketone, so that's B. So that's definitely not it. So what we're looking for here is it looks like it's going to be, since it's the lowest ppm value that we have, that tells us that this is the most shielded out of all of our carbon atoms. And so we can also think of that as being the farthest away from any sort of electronegative group. Right, so when we're talking about shielding, we're talking about how many electrons are actually around that atom. So electronegative groups would pull electrons away from the nucleus, meaning it'd be less shielded and would feel more of the magnetic field. That's the M in NMR, right? Nuclear magnetic resonance. So the one that's farthest away from that carbonyl should be at the very end of this carbon chain. So it should be this signal here for D is what we would expect to be the lowest chemical shift. So from this spectrum, I think we could easily pick out that that signal is D. The signal that's closest to it is probably the one that wasn't an option. So that's probably your signal at 17 parts per million. These two signals here would be difficult for us to differentiate at this level. So this would be difficult to say if they were A or C. And so that isn't something that I would ask you to do at this point. There are some additional techniques that you could use, and some of them are described in your textbook. So some of the things you could use a proton-coupled carbon-13 NMR could be used, or you could use a DEPT, D-E-P-T. I'm not gonna write those down though, because those are not things that you would be responsible for. So from a spectrum like this, I would expect that you'd be able to easily identify that ketone, or maybe the carbon at the very end of the chain that has that lowest chemical shift value. And those would be reasonable questions to ask at this level.